Here we are inside of Visual Studio, and we're going to experiment with the buffers again. Hopefully you remember in the last module that we built an iBuffer of t interface definition to provide an abstraction for different types of buffer. We built a regular buffer on top of that, and we also built a circular buffer that kicks out the oldest items once it reaches capacity. I haven't made any changes to the source code. The only change I've made since the last module is to split out our code into separate files. So now there is a dedicated file for iBuffer of t, one for buffer of t, and one for circular buffer of t. But here's the one new requirement for this module. We have a couple actually, but the first one is that sometimes the developers who need to use the buffer class must inspect the contents of the buffer using a different type. Let's break that down. Some clients of iBuffer need to inspect the contents of the buffer. Well, they already can because all buffers implement IEnumerable of t, so anyone can write a for each loop to inspect each item in the buffer. However, developers want the items to come out with a different type. So for instance, if we have an iBuffer of double, someone wants to scan through the buffer of double and look at each item as an integer to do some special calculation after the double value is rounded. And someone else wants to convert the double to a string to send the contents to a diagnostic logger that only accepts string types. So the question is, how can we pull this off? Well, first, let's take the simple case of converting whatever is inside the buffer to a 32-bit integer. We want this functionality to be available for all buffers, so it's something I want to add to the iBuffer of t interface. And for the simple case of always converting to an integer, I might consider creating a method asEnumerable of int, which will be a method that returns IEnumerable of int, so that each item inside comes back as an integer value. But what about strings? In that case, perhaps I could also have asEnumerable of string that returns IEnumerable of string. But once again, we're facing a scenario where we are writing code and only the type name changes. And as we saw with generic classes, it's valuable to be able to parameterize code using type parameters, so we only need to write the code once. We want to do that when we're duplicating code and only the type name changes. And fortunately, type parameters can also be applied to methods. So I want to write this API using type parameters, and when I do that, I'm only going to have one asEnumerable method. Now I can attach a type parameter to a method, just like I do for a class or an interface definition. I can do that by using angle brackets. But this time the brackets are after the method name, not the class name, and the first question will be, what do I want to name this type parameter? I don't want to call it t, because t is already a type parameter that is in effect throughout this interface definition. And when someone constructs an iBuffer of double, t is already a double. Presumably they'll want to convert double to some other type like int. So I don't want to reuse t here. I want a new type parameter, one that is available just to this method. So let me call it toutput. When you invoke this method, you have to tell me the type of output that you're expecting. And now toutput becomes a generic type parameter that is available throughout this method. When I go to implement it, I can use it anywhere in the method definition. I can use it inside the method. I can also use it in the return type for this method. But I wouldn't be able to use it, let's say, with the write method. I wouldn't be able to use it with the write method unless the write method also has a generic type parameter named toutput. But it wouldn't make sense for the write method. So I'm going to remove that and leave it as is. And now I have a generic interface with a generic method. A generic method doesn't have to be part of a generic type. I could have that method on a non-generic type, and we'll see examples of that later. The next question is, how do I implement a method like this? Let me copy the definition and come over to the buffer class. I'll implement this in the buffer class. That way it's available for both the buffer and the circular buffer, which inherits from this class. Again, the generic method definition looks exactly the same. I want a method, a public method, called asEnumerable of toutput that returns an IEnumerable of toutput. And one of the implementation difficulties that you might face here is how can I take some arbitrary input, I don't even know what it is, it's t, and convert it to some arbitrary output, which I also don't know at compile time, this toutput. Both of those types will be determined during the execution of the program. Well, fortunately, .NET has a class that I can use to get a converter that knows how to convert quite a few different types. If I go to the type descriptor class, and type descriptor is in the system.componentModel namespace. If I go up to that class, there's a static method there, getConverter. And getConverter doesn't know how to do all different types of conversions, but it knows how to do quite a few, particularly among primitive types like ints and doubles and strings. But I have to give getConverter a parameter. One of the method overloads here takes a type, and what I'm going to ask typeDescriptor.getConverter to do is to give me a converter for the type t. If that's double, I want something that knows how to convert double to other things. If t is an int, I want to get a converter that will convert ints to different things. And I can do that by passing t, the type. And it turns out the type of operator will work just fine against generic type parameters. So if this is a buffer of double, I've just asked to get the converter for type of double. And once I have a converter, I could use that on each item in the queue. So let's create a loop for each item in our underlying queue. I'll get the converter to convert to this destination type. I have to pass in the value, that is the thing I want to convert. That's my item. And now I need the destination type. So am I trying to convert a double to an int or a double to a string? I'm not sure at compile time. All I know is that I have t output that represents the type that I want to convert to. So once again, I could use the type of operator and say, please convert that item to type of t output. And then I could return that result. I'll use yield return to build an IEnumerable and return that result. Of course, the C# compiler at this point, if I do a build, will detect that result is typed as object because convert2 always returns object. It's not expecting me to return IEnumerable of object, and the programmer who is using this doesn't want IEnumerable of object, they want IEnumerable of a specific type. Well, that's where I have to assume that convert2 did its job. It's either going to convert something or it's going to throw an exception. And if convert2 properly did its job, then result should be of type t output. So I could use a typecast here to make sure that that's true and basically make sure that the C# compiler is happy with the syntax too. And let's try it out. If I do a build and come back into my program, I have a buffer of double. We're going to be reading doubles in, but let me create a variable as int, which will be buffer.asEnumerable of. And now how do I invoke a generic method? Well, sometimes the C# compiler can infer the generic type that's going to be used, but not always. We'll see examples later where that's certainly true. But because there's no other information that the C# compiler can use here to determine the type of output that we want, we do have to be explicit and say, I want the buffer as enumerable of int. So t for buffer will be type double, t output for the as enumerable of method will be type int, and I should be able to loop through all the items in as ints and be able to see integer values come out. Let's try it by running the program. And I'll input a 2.1 and a 4.9 and a 6.3 and finish. And we'll see that we're getting integers out, 2, 5, and 6. And it just so happens that the converter has done a nice job of rounding for us. What about strings? Would this work if I ask for as enumerable of strings and change this to be as strings? Well, let's try that. Enter in a 4.5 and a 2 and a 1. That seems to run successfully too. Now there are certainly some types that I can enter here where the built-in converters will not know how to take a double and convert it to, let's say, a date time. And if I run this program, the exception that we should see is a not supported exception, but we'll come back and talk about this scenario a little bit later. Right now we have something basic that works for most of the primitive types that people will be using the buffer for. Doubles, integers, strings, longs, floats, all of those are easy to convert. But before we go off and try to solve the harder problem of how do we convert a buffer of double into an IEnumerable of date time, let's continue to look at generic methods and explore a little more about their capabilities.